In this lesson, we'll be talking about properties. Properties that what we use to describe our fluid. They are, as we define them, to be a characteristic of a system to which a value can be assigned. So that means you have to be able to give a number to it. So if you're describing the temperature, a good description would not be it's really hot or it's really cold. You want to say something with a value so you can quantify it, such as it's 75 degrees Fahrenheit or 100 degrees Celsius. So the first thing about a property as we define it is that it has to be quantifiable. The second big thing about a property is that it does not depend on the system's history. So going back to this, the example of the temperature. If you're trying to describe the temperature in the room, if you're describing the temperature of the room right now, in order to describe the current temperature, you don't need to know what the temperature was before. You don't need to know what the temperature is going to be in the future. In order to describe the temperature currently, all you need to know is what the temperature is right now. So we say that that property does not depend on the history of the system. So the two phrases you can use to remember the keys to a property is that it is quantifiable and that it's instantaneous. It only matters about what is going on right now. It does not really matter on the history of the system. There are two categories that we will be focusing on in this course for properties. The first category is the physical property, and that describes it's tied to the property more at a molecular level, described by, it's a property more dependent on the molecular composition of that fluid. And those examples of that can be found in table 1.6. The other category, the one we're going to focus on more, is the thermodynamic properties. And thermodynamic properties based on the energy of the fluid that we're looking at. And those examples can be found in table 1.1. Now there are three types of thermodynamic properties that we'll be using in this course. The first of those is called an intensive property. An intensive property we describe as being independent of a system's mass and size. So a good example of those are temperature and pressure. So let's go back to think about air in your room. If you think about the air in the room that you're in right now, we'll call that air the fluid of the system being your room. So if we were to take all that air, if we would look at that system and we divide that system in half, we now have half the amount of air, half the mass of air. But if we draw that imaginary boundary down the middle of your room, take that half the air, we haven't changed the temperature or pressure of that air. So that temperature and pressure, it doesn't matter how much of that fluid you're looking at. They're based solely on they are not dependent on that mass. They're not dependent on how much of the system you have. So they're independent of the mass and size, and we call them intensive. Another key attribute of intensive properties is that two intensive properties can fix any state. So all you need is to have two intensive thermodynamic properties, and you can fix that state and identify other intensive thermodynamic properties at that state. Another type we have is extensive. It's basically the opposite of intensive. So it does depend on the system mass and size. So looking back again at the system of the air in your room, you take that air in your room and you want to get half the mass now of that room. You're going to divide your room in half. That's going to give you half the volume. So now that property of volume has changed because you've changed the mass of the room. So volume is dependent on the system mass, which makes it extensive. The third type of property we'll discuss is specific properties. Specific properties are a subset of intensive properties. So they are also independent of system mass and size. But they start out as extensive properties that we then divide by the unit mass. So that's the specific property is how we take an extensive property and turn it into an intensive. So let's go, Ben, looking at that volume. If we take that volume and we divide it by our mass, we get the specific volume. So now it is no longer dependent on the mass of the system. One thing to note is in this class, intensive and extensive properties, we will use capital letters. If it's a specific property, it'll be a lowercase letter. So when we take volume, it is capitalized, but when we turn it into a specific volume, we make it lowercase.